Good morning, good afternoon, or good evening, wherever you are. Welcome, everybody, to today's webinar on Parasoft's C++ test, static analysis extension for Visual Studio Code Editor. My name is Ricardo Camacho. I'm a Senior Technical Marketing Manager, and I'm joined by my good friend and colleague, Miroslav Zielinski, Product Manager for our Safety Critical Solutions. We are very excited to share with you today some great information and content that we have on our extensions to the very popular Visual Studio Code Editor. But before we jump into the presentation, let's go over some housekeeping with Zoom. Okay, first, everybody's microphone has been muted. However, if you have questions, please enter them into the Q&A dialog. You should see the Q&A button in your Zoom control panel. And also, if you run into any technical problems like not being able to hear audio during the presentation, please use the chat channel. There, you can connect with one of our team members who is ready to respond. So let's run through a quick check to make sure everybody can hear me. Would someone click the raise hand button inside your chat channel if you can hear me? All right, perfect. Thank you. Okay, it looks like we are ready to go. Go to the next slide. There we go. All right. Now, on today's agenda, Miroslav is going to start the presentation by discussing evolving trends that are noticeable out in the field that are making productivity impacts to our overall workflows. For example, the lightweight Visual Studio Code Editor with its marketplace full of extensions, which continues to proliferate the software development industry. And there are other tool chains that Miroslav will touch on, which continue to enhance our workflows, making developers and testers more productive. Some of these productivities are being borrowed from the enterprise IT space, like containers and virtualization and more. We also have a very special treat for you today. Miroslav is going to give us a live demonstration. So you'll get to see our solutions in action, and very important also is how easy our tools are to deploy. So this is really very exciting stuff. Okay, let's start by asking Miroslav, our product manager and friend, to give us a brief summary of some of the modernizations that are happening in the software development industry and how Parasoft is contributing to it.
Thank you, Ricardo. Hello, everyone. Today, we're going to focus on the latest release of the Parasoft C++ test 2020.1 and the brand new static analysis extension for the Visual Studio Code. Our discussion will be focused on C and C++, especially in embedded and safety critical space. But I would like to mention that we have also released Parasoft.test static analysis extension for Visual Studio Code, which supports C# development. Now, before I demonstrate our extension for the Visual Studio Code, as Ricardo mentioned, I would like to discuss some of the trends we see in the industry and try to answer the question why lightweight tools such as the VS Code are becoming so popular in the embedded and safety critical space where most of the C and C++ code is now developed. So in the last years, many of the teams noticed that they are no longer able to develop their products and meet the market expectations using the tools and methodologies from the past. Ubiquitous connectivity of embedded systems and AI-based algorithms cause the size and complexity of code bases to explode. And because of this, We're observing now a huge changes in the development environments, methodologies, and the workflows. The embedded and safety critical space, which was traditionally slower than enterprise IT for accepting novelties because of prevalent certifications and audits, is now under the pressure to modernize. Growing embedded teams started to look into the methodologies and tools their colleagues from enterprise IT sector were using for years, and they started to adopt agile feature branch development model, CI/CD, containers, and all these lightweight tools that are capable of dealing with the large code bases. Of course, these trends do not affect all the teams. There are and there will be products which can be developed by a small team using old style approach. But in general, the pressure to modernize will be growing, especially for the large teams developing complex functionalities such as AI-powered ADAS systems in the automotive. And from our observations, we see a growing acceptance for Linux and open source tools. Git, CMake, Jenkins, GNU compilers, LLVM compilers, Docker containers. These are now bread and butter for most of the teams. Whenever a specific tool is not critical from the safety and security perspective, teams prefer to select open source solutions because these tools are proven to work very well in the large projects and deal with the large code bases. So Git, Jenkins, Docker, CMake, and of course, the Visual Studio Code are all good examples here. For the tools which are critical for the functional safety, security, and the certification, teams still prefer the commercial solutions and having a real vendor that can support them with the rollout, tool qualification, certification, or simply with bug fixing. So what are the expectations that dev teams have now for the development environments? With the complexity and the variety of the tool chains, teams try to avoid traditional setups where all the tools are installed directly at the developer's machine. This is becoming too expensive to maintain, and with all the dependencies between the tools, basically too fragile. Teams want to be able to get up and running with their tool chains for the specific project in the similar way they get the source code. Just pull the configured tool chain from the repository and be ready. And containers are very handy here. We had an interesting webinar recently which discussed how containers simplify the management of the tool chains. If you didn't get a chance to see it, please register to see the recording. Other thing is that teams also prefer now the tools that can be configured with plain text files or with human readable formats like JSON or Java properties, which can be stored together with the code and, if needed, to be modified with automated scripts. Complex GUI-based configurations stored in proprietary formats are, we may say, the song of the past. Expectation is take a new machine, possibly a VM, just with the operating system, check out the code and configurations, pull the containers with your tool chains, and be ready in minutes. And last but not least, the critical expectation now is that the testing tools and processes are fully automated and well integrated with the workflows and with the other tool chains. So create a feature branch, develop the code, test your code locally, run more extensive tests in the CI/CD, create the pull request, and be done. Static code analysis, coding standard compliance, and unit testing need to be a part of these workflows. And Visual Studio Code fit this picture very well. It's got multiple advantages over the traditional feature-rich or we may say feature-heavy IDEs that make it a great match for these modern workflows. Parasoft tools support integration with the traditional IDEs like Eclipse and Eclipse-based embedded IDEs, Visual Studio, and collection of other smaller embedded IDEs. But in the last years, we see the growing popularity of the Visual Studio Code. When talking to our customers, we frequently hear that Eclipse or Visual Studio are becoming problematic for large code bases, which are now very common in the industry. Both Eclipse and Visual Studio, they offer great features and advanced functionalities. We get excellent support for debugging and accurate IntelliSense or code completion, however you want to call it, but these IDEs are heavy. It may take, for example, a couple of minutes to start the large Eclipse workspace. And the navigation between the components of the workspace may generate a lot of frustration. We see that, again, and this is based on the interactions with our customers, that in some projects which contain millions of lines of code, developers even prefer to use Emacs or Vim instead of heavy IDEs. And VS Code places itself somewhere in between plain editors like Emacs, Vim, or Notepad++, and heavy IDEs like Eclipse or full-blown Visual Studio. It's lightweight and fast. At the same time, all the essential functionalities like the code completion and debugging are supported in the reasonable way. Code completion may not always be that accurate, and you may be missing some advanced debugging capabilities, but for, say, 80% of your daily activities, you get what you need and it works fast, facilitating your dynamic development pace. And the crucial thing is that VS Code has an open architecture. It is easy to extend and offers a marketplace full of plugins, such as the Parasoft C++ test, which enriches the capabilities of these editors. And with our extension for the static analysis, we wanted to keep the spirit of this ecosystem. So our extension is easy to install, easy to configure, and intuitive to use. So I will go now through the three representative workflows with the Visual Studio Code and the C++ test static analysis extension, trying to highlight the important elements of the setup. Let's start with the simplest, most fundamental workflow. Here we can see the setup that is typical for developers working locally on their machines. Developers pull the code from the Git repository to their local drives, and they develop the code or work on a bug fixing using the VS Code. On each modification, the local build process starts, which typically includes the static analysis and possibly also some small amount of unit tests. With the Parasoft C++ test extension, static analysis is very easy to integrate into this workflows. Let me bring back the slide deck. All important actions, such as running the analysis, reviewing results, viewing documentation, or suppressing the findings, can be done from within the VS Code. What is important from the process point of view for this kind of workflow is that developers expect immediate feedback for the changes they introduced. So the response from the static analysis should be as fast as possible. For this kind of setups, we recommend enabling the limited amount of static analysis checkers without the checkers that work on the project scope and take the long time to report feedback. This way we are sure that, for example, 80% of the problems will be found immediately after the code was created, and the cost of our process will be low because of that. And the remaining static analysis checkers will be executed in the CI/CD pipeline, providing the feedback a little bit later to the developers. In this workflow, the developer can start the analysis for the files that are currently worked on directly from the VS Code. The results are reported back in the editor for convenient review and remediation. It makes the workflow smooth and efficient, and I will be demonstrating it in the second part of our webinar. The second workflow I would like to discuss is for the remote development. Even though the diagram looks very different from the previous one, from the user perspective, this is a very similar situation to the previous one. What we have here is the developer using the local installation of the VS Code, for example, Linux or Windows machine, connecting to the remote server for the development. The source code is pulled from the repository to the remote server. The build toolchain, like compiler, build engine, and the static analysis tools are all located in the remote server. Developer uses VS Code as a quote thin client to access the development tools installed on the remote machine. So user can easily build the code with the remote compiler and also perform the static analysis. And this is a great function. This great functionality is possible thanks to the remote SSH VS Code extension. The remote SSH extension lets you use any machine with SSH server as your development environment. This can greatly simplify development and troubleshooting. You can use Mac, you can use Windows, and still be able to develop, for example, on the Linux platform. And any combination of these operating systems is supported here. And this sounds very interesting, especially now in the current situation where most of us need to work from home. With this kind of setup, you don't need a specialized powerful machine. You can use any computer you have available at home and connect to your development host in the office. And the great thing is that our extension for the static analysis was designed in the way that it can be also used in this kind of workflows. Static analysis can be executed on the remote machine, but results will be immediately present in the local VS Code client. So you can browse the results, fix the problems, or suppress violations directly in your local VS Code instance. And again, this is something we'll be demonstrating in the second part of the webinar. In this kind of workflows, we still expect the static analysis to return the quick feedback because developers are interested to see the results as soon as possible at the time when the code is created. So more advanced static analysis checks will be still performed in the CI/CD pipeline. Great advantage of the VS Code and Parasoft static analysis extension is that it seamlessly bridges the gap between your local machine and the remote development environment, giving you very same experience as in the most typical local development workflows. And finally, we have the CI/CD. In this workflow, developers are working on their local machines, which are prepared and configured for the development using, for example, Docker containers. Developers work on the code locally, and then at some point they push their code to the repository, which triggers the CI/CD pipeline. And CI server executes the pipelines, which include building the code, but also running the static analysis and perhaps unit tests, integration tests, and automated system level tests. From the static analysis perspective, this gives us a possibility to perform more thorough code scans with the richer set of static analysis checkers, since the CI servers are usually very powerful machines, and we can expect that even in-depth static analysis will be performed in the reasonable time. And result of these testing activities, such as static analysis or unit testing, are sent to Parasoft DTP, which is a central reporting system and aggregates the data from multiple testing practices and correlates them with the information from the source code repository and requirements management systems. To simplify the illustration here, SCM and RMS are not reflected on this diagram. Great functionality of DTP is that it enables dedicated compliance reports for the coding standards such as MISRA, AUTOSAR, CERT, CWE, or OWASP, and it is a great help for achieving compliance. Developers can access these interactive reports with charts using regular browser, but they can also download the findings directly to their IDE for the local review and remediation. The functionality to import results from DTP to the VS Code is coming in our newest release, but right now users can download the results generated at the CI level to their VS Code instances using import results file functionality, which I will be showing in a minute during the demonstration. So to summarize CI/CD discussion, from the static analysis perspective, in this kind of the workflow, we are interested in performing deep and thorough analysis with the complete set of checkers and be able to present results back to developers for remediation. Developers can check the results and interactive reports directly in the DTP and see their progress with compliance. But for code level analysis and remediation, they will want to import the results, static analysis findings to the VS Code and act on findings inside their favorite development environment. And this concludes our short journey through selected but hopefully representative workflows. Ricardo, back to you. Okay, I see we may have some problems with connection, so I will continue. So we are at the demonstration part now, and for the demonstration, I would like to show you a simplified setups for each of the workflows we were discussing. In the first part, we will focus on the functionality of the Parasoft static analysis extension for the VS Code. I will walk you through the selected features of the extension. In the second part, we will see how our extension flies in the remote development setups. And finally, we will go through the simple example of the CI/CD workflows where the results of the automated static analysis scans are downloaded to the Visual Studio Code at the developer's desktops. So let's start with the first demonstration. I will focus on the local workflow with static analysis. So let me stop the presentation mode. And for the demonstration, I will open the Visual Studio Code. So this is the VS Code installed on my Windows machine. Here I have in my workspace, I have my project. This is the code I developed. And let's say that for this code, I want to implement static analysis. I want to achieve MISRA compliance. What do I do? Well, I can go to the marketplace and search for MISRA, for example. And the first thing and the only thing that appears is Parasoft C, C++ test static analysis extension for the VS Code. So I can install it, which takes only a second, and I'm almost good to go. To complete the installation, I need to do one more simple step. I need to install Parasoft C++ test standard, which is the static analysis engine which interacts with the extension. And the extension gives me a gentle hint to do it. I can click here to learn more, where I have a description of the remaining steps. I can check the website. Here you can request the free trial of Parasoft C++ test standard and download it to finalize the installation. Installation of Parasoft C++ test standard is trivial. All you need to do after downloading the distribution is to unpack it to the directory of your choice and drop the license file to this directory to complete the installation. I've done all these steps already, so we are almost good to go. After the installation, the VS Code status bar contains the quick start menu, which will help us to finalize the configuration. So once we click the quick start menu, we'll be shown a couple of simple options, and we can finalize the configuration. The first thing we need to set is point the extension to the installation of C++ test standard. So by clicking here, we can point the extension to the place where we unzip the C++ test standard. So this is done. Then we need to select the test configuration. So the collection of static analysis checkers we want to use to scan our code. So let's say I mentioned MISRA, that I want to test my code against MISRA. And the last thing is we need to select compiler configuration. Basically, we need to tell the tool what compiler we are using for building our project. In my case, this is GCC 9 compiler 64-bit. So I'm selecting it, and that's it. And we're done. We can start the analysis. So I will click here to analyze entire project. And what is happening right now, the extension started the analysis process. We see the progress on the output view. You see that some violations were already found. And after the analysis is done, all the static analysis findings, all the problems located in the code are loaded to the problems view. So we can now easily browse through them, analyze, and take appropriate actions. Findings are also displayed as the drop downs in the editor. So if you hover on these underlined locations in the code, you can see the information about the static analysis results. So let's take a quick look on a couple of examples. Let's say that we want to I don't know. We can search here by the phrase from the reported finding. So we can double click here and see what is the problem reported here. And C++ tells us that the expression of the essentially signed type is assigned to an object with the essentially unsigned type. So if we don't understand what this problem is about, we can easily open the rule documentation. We can put it side by side, every rule is documented with the description. It includes also the example of the violations and includes information what are the typical repair actions. So all this information is available here. We can also look for some other problems. I'm using now the ID of the specific MISRA guidelines. Let's take this example. Record is checked for null after being dereferenced. And with this type of findings, which span across, which describe problems that span across many functions, possibly even files, we get the full information with a convenient trace, which shows us step by step why given problem appears. And here we have the first element of the path where we have a query function. Inside the query function, we have the referencing of the record variable, then it's returned, and then it's being checked for null, which is not a good practice. And also here we have another example of a violation, possibly accessing array timer records are out of bounds at index -1. So again, we have a path. So we can see that start of the path. This is in an init timer function. We have a loop, and from inside this loop, delete timer record function is called. The loop runs from 0. So the first invocation of delete timer record will be with a 0 parameter. And if we go inside, we can see that we have another loop. And in this loop, we are initializing the index to the function parameter -1, which for 0 will be -1. And then we are trying to access the timer records array using this index, which will be -1, which may be a problem. We have also other options here once we analyze given violation, and for example, we don't agree with it, or we have a good reason to accept this violation in the specific place. We can easily suppress it using a drop-down action from the problems view, and I can add a comment why this is acceptable. Referencing some permit, and C++, the extension will automatically generate appropriate comment in the code, which will suppress this violation from appearing in the subsequent sessions, analysis sessions. So this concludes the first demonstration for the basic workflow for the local development workflow. Let me quickly bring back the slide deck to quickly discuss what we are going to see in the second part of the demonstration. In this demonstration, I will show you how you can use VS Code and C++ test extension for the remote development setups. Here we will have Windows machine with local installation of VS Code, which will be connecting to the remote Linux server, which sits in my office. And this server is configured for the development. I have all the compilers I need there. I have CMake, and I also have Parasoft C++ test for static analysis. So let's see how we can implement this kind of workflow with the VS Code. So I will start Visual Studio Code one more time. This shows my local workspace, and this is not what I want to do. I will now use remote SSH to connect to a host, and this is my development machine in the office. So a new instance of VS Code is started, and it asks me for the password to connect to the local to the remote server. And now I'm connected. Let me expand. I can open the folder with my source code, and this is the remote file system. So I'm pointing to the directory where the source code is located. I need to type the password one more time. And I'm connected. I'm sitting on my Windows laptop where I don't have any tools, development tools installed, but I'm connected to the remote server, and C++ test is available there. So I can run the static analysis on the code. And as you can see, this is executed on Linux. So it's completely transparent for me that I'm working with the remote development host. The build process is managed, can be managed by the VS Code, and the static analysis, as you can also see, is fully automated. It's executed on the remote host, and as soon as the analysis is done, I see all the results. So I can browse, I can review, I can suppress. All without having the development environment installed on my local host. So that's the second workflow I wanted to present. And again, let me bring the slide deck back to quickly introduce the third part of the demonstration. We will be talking about the CI/CD workflows, and I will present a subset of the workflow here. I will start with modifying the code on my local development laptop. Then I will push the code to the Git server, which will trigger the CI/CD pipeline. In my case, I'm not using Jenkins. I will be using CI/CD based on the GitLab. And in my pipeline, the code will be built. Static analysis will be performed, and after the static analysis, which will be performed with the extended configuration for in-depth code analysis, I will show you how to download the results to my local installation, to my local instance of the VS Code for the analysis of the findings. So let's go back to the VS Code. Okay, let's close the remote setup. Okay, just a minute, and now I will open my local directory. This is again the source code on my laptop, and now let's say I'm working on the new feature. I will implement a piece of code. Let's say that's something simple. A plus B, nothing really sophisticated. I'm done. I'm saving it, and this is something I want to commit. So I'm staging the file, and working on the feature XXX. That's my commit, and I'm pushing my changes. And now the code was commit, and let me move now to my CI/CD. As I mentioned, this setup is based on the GitLab. This is one of the examples, and I can go to the pipelines, and I see that my commit triggered the action. Pipeline is already running, so I can enter here. I can check the static analysis. I see that static analysis was already executed. Some violations were reported. And again, in this workflow, we assume that this is more thorough configuration, which contains more checkers, which are executed on our powerful CI server. And we can drill down here for the static analysis. We can browse the reports. We can browse the report, and we can download the report XML to our local drive, and now it is available for us to be downloaded to the VS Code. I will use command palette right now to see all the actions that are supported by C++ test. And I will select load results from file. And I will pick the latest one that was generated. And with this action being done, I can see all the findings that were generated during the CI in locally on my laptop, so I can work with them. I can analyze the code and fix or suppress. And this concludes the demonstration part. So let me bring back the slide deck.
And can you hear me?
Yes, I can hear you, Ricardo.
Thanks.
So back to you.
Sorry for that. I lost the audio on that. Anyways, that was actually very impressive, Miroslav. You actually painted a very clear picture of how our solutions are seamlessly integrated and how they can support these three workflows that you actually mentioned, and how this can work in your organization for the folks out there. Anyways, Miroslav, can you also do a quick recap?
Sure. So we have discussed how the growing complexity of the systems and the growing size of code bases drive the evolution of the development tool chains and workflows. We have discussed which features are now expected from the tool chains. Tools need to be fast, customizable, adaptable, and lightweight to be manageable with containers. And finally, we have seen how Visual Studio Code with Parasoft C++ test extension for the static analysis fits into this picture. Our discussion was focused on the C and C++ part of Parasoft portfolio, but let me repeat one more time that the same VS Code extension is available for the Parasoft .test. And with this being said, I believe we have reached the end of the presentation. Ricardo, back to you.
Okay, go to the next slide here. Come on, there. Oh, not too many. Maybe you can click back for me. Somehow it's not.
Okay.
Okay, thank you. So yeah, let's make sure you know where to find Parasoft's extension for VS Code. Here's the link and a barcode for Microsoft's Marketplace for C++. And so you can go ahead and try out the C++ extension. Or as Merrick mentioned, we also support C#, so look for .NET. by going to the marketplace. And what you're going to find in there is a lot of prerequisites and getting started instructions. So in no time, you're going to be building safer and more secure applications with your static analysis solution that we offer. Okay, yeah, can you go to the next slide for me?
Yes.
Thank you. So let's go ahead and open things up for questions. Let me take a quick look here. Okay, Merrick, we have a question here. Can I customize the environment to support my own defined rules?
Yes, this is supported. You can, the configuration, you can extend existing configurations. The tool is shipped with the collection of, we call them test configurations, which are basically a pre-selected checkers, like for MISRA compliance or CERT compliance. So you can edit these configurations and you can enable additional checkers. In total, Parasoft C++ test supports more than 4,000 different static analysis checkers. So you can pick and choose whichever are right for you, probably in addition to the compliance standards such as MISRA or AUTOSAR or CERT. And also C++ test supports creation of the custom checkers. So if you need to scan your code against your specific code patterns that are typical for your libraries or your projects, you can create these checkers, or you can edit, customize existing checkers and include them in your static analysis scans. Okay, so I will continue with questions. Let me see what we have here. We have a couple of more. What is your plan with integrating unit testing into VS Code? Okay, so unit testing is supported by C++ Test Professional, which is available as a plugin to Eclipse and Visual Studio. Our current release of Visual Studio Code extension, which is different from Visual Studio, does not support unit testing yet. But given how quickly this editor is growing, this is definitely something we are considering for one of our future releases. Okay, another question. Do you plan to support VS Code extension for Java? Yes, in general, we plan to support VS Code extension for Parasoft JTest, which is a code quality tool for Java. We do not have yet fully defined plan for which release it will be supported, but this is definitely something we are considering. Let me see what else do we have here. What is considered remote? Only the cloud or also another machine on the same LAN? Anything basically that you can connect to through the network. So it can be a local machine on the same LAN. It doesn't have to be something in the cloud. That's the remote development model I was showing. That's the feature of Visual Studio Code. That's not a part of Parasoft C++ test extension. However, our extension works with this development model. Another question, are you using GitHub or GitLab? The presentation I was showing was with GitLab, but this was just an illustration of the CI/CD workflow. You can do very same things with Jenkins, with GitHub, with Bamboo, and with any other CI tools. Again, this was just to illustrate what you would normally implement in your real development. Another question, how do I use Parasoft to perform static analysis for MATLAB/Simulink generated C code? This is not any different from static analysis on the regular handwritten C++ code. So all you need to do is just to open the code in the VS Code and then specify the information about compilation options. That's a part of the configuration process I was not showing today, but it's relatively simple and it's well documented. So there are no limitations here. Any valid C++ code, including the code generated from MATLAB Simulink or other modeling tools, can be statically analyzed. So let's maybe see one more question. Can I suppress coding violations and at what levels? Actually, this is something I was showing during the demonstration. So when you have a finding in the VS Code editor, you can use the drop-down menu item to initiate suppressing, and then editor will ask you for adding the comment for the suppression. And with this being done, a special comment in the code will be generated. So you need to commit this with your source files, and this will be an information that is interpreted during the static analysis by the code analyzer, and this suppressed violation will not be reported. Violations can be also suppressed using the DTP server. So if you are sending results to the Parasoft DTP and you review and you triage the results in the Parasoft DTP, you can also suppress inside DTP, and these suppresses will be honored by the VS Code extension. The violations will not be shown. Okay, let me see if we have other questions. Is this just extension? Is this extension just a linter? No, Parasoft C++ test is more than just a linter. We do thorough data and control flow analysis. So we can find problems like runtime problems, like buffer overflows, integer overflows, dangling pointer, null pointer dereferencing. All these type of problems, errors can be done, and this is done by advanced code analysis by PAPS simulations. Okay, I still see we have many questions. I believe we will try to answer them through the email. So I think we have just enough time now to conclude the webinar.
Okay. Well, thank you, Miroslav, for a wonderful presentation and going through all of those questions. Now, today's webinar has been recorded and will be made available later today along with the slide presentation. So expect to receive links to the collateral. Also, take a look at our blogs on some of the topics that Miroslav discussed. They provide a lot of technical value, and we also have webinars that complement the blogs. Now, please subscribe to our YouTube channel or follow us on Twitter, Facebook, or LinkedIn. And you can also reach us via email at info@parasoft.com. Now, don't forget to visit our website, parasoft.com. You will find additional information and other fantastic solutions that we offer. Anyways, better yet, evaluate our products for yourself. So there's a little bar so that you can follow and go ahead and install and get a trial of our product. Anyway, stay safe and healthy, and thank you again for attending. Bye-bye, folks.